Welcome. Let's graph some inequalities. And we're going to do them with the two variables ones. And let's talk about the idea of what's happening here. We're going to simply graph a line. And let's say it was like a dashed line like that. And once we do a dashed line, we're going to find out which side to shade. So the side that's shaded has all the answers that would solve it and make the inequality correct. And the other side, they're not correct. So that's our goal, is to find the right shaded area. And that means we have to first graph the line. So let's talk about it. One, graph a line. And then two, shade it. Now, there's a couple of little details there to make sure we get them right. So let's do those. So first, the easiest way to graph any line, if it's an inequality, is first to make it regular equation. Temporarily, we're going to make it equation. And then there are two ways to graph it. Two ways to graph. One of them is to do an XY table, and the other one is to change it to Y equals MX plus B format. There's a third way too, which is using the X-intercept and the Y-intercept, and both of them are perfectly fine ways to do it. One, two, and so I guess you could say the third way is using the intercepts. But that one's not as common for no other reason than most people just don't use it, but you could if you wanted to. And right now, though, I'm going to focus on the one of these, and I'm going to do the Y equals MX plus B. So that means I need the Y to be by itself. And here, the Y came first, which is interesting. Usually it's the X term, then the Y term. So let's add 4X here so that we can start getting the process of getting the Y by itself. So that's 2Y is equal to 4X plus 6. And divide by the 2. And I get that Y is equal to 2X plus 3. So now I'm going to put that line on there, but here's the step that you have to next watch. And that's this inequality. So do we do that as a dashed line or a solid line? And that's where you have to remember that the equal signs underneath it means solid lines, because that means the points on that line are equal, as opposed to these where it's a dashed line. Dash line. So this one looks like it's going to be a dashed line because it doesn't have a little equal sign underneath it. So I'm going to graph this. I need to go to positive 3. And then I have a slope of 2 over 1. 1, 2, and 1. 1, 2, and 1. 1, 2, and 1. I can also make the slope the opposite numbers because that still means the same thing, but it lets me go down 2 and over 1 the other way. Down 2 and over 1 other way. Down 2 and over the other way. And then what I have to watch for is that this is a dashed one. So instead of doing the solid line, and dots are okay too. Dots are dashed, because it means the points on that line do not satisfy this. This is the original equation, and all the points on the line would make it equal to, but this is not an equal to, it has to be greater than only. Okay, so then what we need to do for the shading, we test a point. And the easiest one is 0, 0 if it's not on the line or very close to it. So right here is 0, 0. I'm going to put that into the original equation. And if it's true, that means we'll shade on this side. If it's false, we won't shade there. We'll shade on the other side over here. So let's find out. So I'm going to take that original of 2y minus 4x greater than 6. I'm going to put a 0 in for both of those. That means I have 0 minus 0, which is just 0 greater than 6. But 0 greater than 6 is false. And if it's false, then you shade the other side. And it doesn't have to be every tiny little space, but make it reasonable. So it's very clear where the shading is supposed to be. So that has been correctly shaded. And all of these points over here, any one of these points in this whole area will make the statement true. So I could take the x and y from those and plug it back in over here, and it would give me that it's greater than 6. 0, 0 didn't work because that was on the other side, and it made it false. But every point in the blue area is now true. Let's do it again here. And for this one now, figure might as well, let's put in a couple, let's do this one doing an XY table. I prefer doing slope-intercept form, but I don't mind doing an XY table to illustrate it. So what I need is like at least 3 points, and for X, I'm going to put, I see all even numbers here, so let's put even numbers. So let me put a 0 and a -2 and a +2. So here, if I put in for X, -2 plus 4y is less than 2. Well, actually, this is where I need to make it an equal. Okay, -2. So temporarily make that equal, plus 4y, and that was the X. Plus 4y is equal to 2. So I'm going to add 2 over here. Okay, and that gives me 4y equals 2 plus 2 is 4. Okay, so then I'm going to divide by the 4, and I'm going to get that y is equal to 1. So at -2, I'm at a 1. So if I go to -2 and go to +1, there's a point. Now I'm going to do it with 0. So 0 plus 4y equals 2. 4y equals 2. Let's divide by 4. Ooh, y is equal to 1/2. 1/2 or 0.5. What that means then is at 0, we're like halfway towards 1/2. And for 2, I'll do that one over here. So for x, I'll put 2 in, plus 4y, less than 2. Subtract 2, subtract 2. 4y is, oops, and I meant to put equal here. 2 minus 2 is 0. When we divide by 4, y is equal to 0. So that means that when x is 2, y is 0. And we have 3 points where we can graph it. In hindsight, I'm thinking if I'd used 4s, that might have been better, a little farther away. But these are still exactly, 2 of them especially are on these intersections, and that makes it look like it should be fine. Is it solid or is it dashed? It looks like this one is, again, a dashed one. Oops, not what I wanted to do. Let's bring it back up. It's dashed. So let's set this back in its right place. Okay, let's bring the, now there, that looks pretty decent. So that means I'll put dashes here. Ooh, that came out pretty well. Now we have to test an area. Okay, so I'll take some space over here and I'll test. Now 0, 0 is here. It looks like it's below it, so it's perfectly fine to use it. And it is easier to use. I think I'm going to choose a different one here. I think I'm going to go and choose something like 0, like let's go way down here on this one. And if I choose this point, the x is 0 and the y is -10. Okay, or I can choose one above it as 0 and +10. In fact, let's have less negatives here. Let's put this one 3, 4, 5, 6, 7, 8, 9, 10. So this point here is 0 and 10. It's clearly on the top part. So let's test it. And to test it, I go back to the original. So for testing it, I have x plus 4y less than 2. So for x, I put in a 0. For y, I put in 10. 0's gone, and I get 40 here. 40 less than 2. Uh-oh, that's not true. That's false. 40 is larger. So because it's false, that means we do not shade the area where 0, 10 is. So what we'll do here is we'll go and shade the other area. I'll go down here, and we'll shade this area. So all of the possible good solutions for this are the x and y points that are in this shaded area. There. Okay, looks good. Not necessarily perfectly neat, but on purpose I'm doing that because I don't want people to agonize over how perfect to shade in one side or the other. Just make it clear and obvious. Now here we're going to do a couple of little exceptions here. Let's figure out what's happening here. Let's solve this one, but this one doesn't have an x and a y in it. So actually solve it. Let's go ahead and like figure out what the equation is. So in other words, let's do this kind of thing. 2x less than or equal 7 take away 3 is 4. Divide by 2. X is less than or equal to 2. So figure out where x is equal to 2. And that's this line. Now notice that it's a greater than, or I mean a less than or equal to. So for x equals 2, I will do this. So part of why this problem is in here is to remind you about vertical lines. When you have an x equals 2, it's a vertical line. And if it's an inequality, we just figure out what numbers are less than 2. 1 is less than 2, 0 is less than 2. All the negatives are less than 2. So we're just going to shade this side. There. Make it clear that it's there. And that's correct. That's done. Let's do this one where it's just a y in it. So we'll add 7 both sides. For y is greater than 12. When I divide by 4, y is greater than 3. So let's figure out where y is equal to 3 up, but I see that it's supposed to be a dashed line. So y equals 3 at this point. Well, y equals 3 here and here and here and here and here and all of these points. Y equals 3 at every one of these points because it doesn't matter what the x is. Y is still 3. So in order to do it, though, I need to do dashed lines or lots of dots. I just like the dashes especially. And then the numbers that are greater than 3. So 4 is good, 5 is good, 6 is good, 7 is good. It's all the y's that are up here. The x's don't matter here because no matter what the x's are, y is greater than 3 for it. Okay. So that's the correct shaded area there. So remember about horizontal and vertical lines for x's and y's if they're by themselves. Let's take a look at an application problem now. Rajan writes and edits for a newspaper. It takes him 1 hour to write an article and half an hour to edit an article. And he works up to 8 hours a day. How many articles can he write and edit in one day? Okay, so we're looking at a combination. So let's think about the information that's here. Okay, so if he's going to write articles in one day, he can do 8 of them because it takes 1 hour each, 8 in one day. I got that because they're 1 hour each and he has 8 hours to work with. If he just edits them, that's if he writes 8 in one day. If he edits, he can do 16 in one day. Okay. So that's because he only needs a half an hour. So every hour he can do 2 of them, and if he's got 8 hours, that makes for 16. So, however, also let's say here, write came first. So let's say that's our x, and edits are our y's. Okay, so we're going to make a graph with that. But before we do, let's point out that when we have 8 of them written, we have 0 of them being edited. Write and edit. Write and edit. And then for editing, that means 0 get written and 16 of them are edited. So with that, we can do an equation. Right? So what we're going to do here is make a graph with it. And because of x's and y's, x's are down here, y's are here. These are written articles. And this is edited articles. Write and edit. All right, so let's think. We need to go up to at least a 16 on these. So here we have lots of them. We actually have 20 spaces. So let's actually go up to 20, go a little bit past it. So that's a 0 here. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20. I'll do the same thing this way. 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. Got a better 0 and 20. So now what I'm going to do is put these on. We have actually two choices here. I could make an equation, right? But first I'm going to put these points. Let's put z. Do that in blue. So 8 and 0 is here. 0 and 16 is here. And I'm going to draw a line between them. And I'm not going to put arrows on this line because we can't actually go back. We can't go to negative articles or to negative written articles or negative edited articles. We can't really do that. That's not reasonable here. Okay, so now what we're going to think about is the equation, like which way do we shade here? So let's make an equation out of this. If I'm going to do a y equals mx plus b equation, and then we'll figure out about the greater than or less than afterwards. Let's find the slope. So for m, we have 16 minus 0, and we have 0 minus 8. So this is x2, y2, and this is x1 and y1. Okay, so that gives me 16 over negative 8, which is equal to a negative 2 slope. And then we need the y-intercept, which is what this is. That's the y-intercept, because when the x is 0, the y is 16. So we have y equals negative 2x plus 16. But now what we need to figure out also is the greater thans and less thans. So right now, let's think a little more closely about this. The writing, you have to have less than or equal to that 8, less than or equal to that 16 for the editing. So over here, let's think about points. If we take a point somewhere here, let's just think about it as reasonable. Let's take 10 and 10. Okay, that's 10 written articles and 10 edited articles. But the maximum we could have of written is 8, so that doesn't make sense. We could have up to 16 edited ones, so that could be a possibility here, except that we can't have this one because that's going to be too many hours. That would take us 10 and 5, that would be 15 hours because of 10 hours and then half hour for each of the 10 edited ones would make 5 hours. So it's 15 hours, and it's way over the 8 hours. Let's pick one of these on the inside and see. So it's not reasonable for it to be a greater than. Okay, and this would be greater than area. Over here, let's pick something a little different. Let's take this one where it's 2 and 3. That means it's 2 written ones and 3 edited ones. This would be 1 hour, and this would be 1.5 hours. So it would be 2.5 hours, and that would be okay. So it looks like it's all the ones that are less than, but also the ones that are actually on it, because it says you can write exactly 8 in one day, exactly 16 in one day. So that means we're going to change this to a y is less than or equal to negative 2x plus 16. So the directions did not say to write an equation, but if it did, then this would be a good equation for it. But what it does say is how many articles can he write and edit in one day if he works up to 8 hours. So let's look at the choices that are here. If he works up to 8 hours, that means that it's really the ones that are on the line. So this is a good answer. This one at that intersection, this one, and this one, this one, this one, and this one, and this one, and this one. All the ones that are here are going to be less than 8 hours. All the ones that are here are going to be more than 8 hours. Okay. More, less, and then these are exactly 8 hours. all of those others. So what the answer is going to include is going to be include those points. So let's actually identify those points. This one is 7 for the written, or X's, and 2 for the edited, which makes sense. 7 hours, and the 2 is 2 half hours. That makes 1 more hour. That's 8 hours. And this one is going to be 6 and 4. And this point is 5 and 6. And here we have 4 and 8, 3 and 10. And here we have 2 and 12, 1 and 14, and 0 and 16. So how many articles can he write in one day and edit in one day? So 1, 2, 3, 4, 5, 6, 7, 8 answers. 10 written and 0. I'm going to start at the top with these. 0 written and 16 edited. 1 written and 14 edited. And I got that from this and from this. And then 2 written, 12 edited, 3 written, 10 edited, 4 written, and 8 edited, 5 written, 6 edited, 6 written, 4 edited, 7 written, 2 edited, and 8 written with none edited. And now I'll go back and put these semicolons in here. So I'm going to summarize the answers that way simply because it's a whole lot easier than to, okay, let me get these back in here. 7 written, 8 written. Bring that back down. So this one is an application of it to determine how many that the person can do given the restraints of 8 hours and 1 hour for each written and a half hour for each edited one. And so we have 8 possible acceptable answers here. And now you see how you can use a greater than or less than concept, because all of these could be done too. Okay, so this could be thought of as let's pick a few points and which ones would satisfy the requirements, and all the ones inside the yellowed area here would satisfy, or on the line would satisfy the requirements. Okay, I hope that helps about graphing inequalities. Make sure you really think about the shaded up here, like how to shade, how to get the line, making dashed or solid lines. You want to make sure you're very comfortable with that so that you can always get them right. Thank you for watching and listening.